Welcome to the proofs of lesson 3.3. Now normally I had a lot more to this, but we had our notes separately from our theorems, and hopefully we have some time in class to walk through these because we can take more time and make sure you fully understand it. But hopefully this video will serve as a means for you to review if you need to. Corresponding or converse of corresponding angles postulate says that if two lines are cut by a transversal so that corresponding angles are congruent, then the lines must be parallel. So we use this when we have corresponding angles congruent to conclude the lines are parallel, and we use this as our reason. The hypothesis is I have two lines that kind of look parallel, and I got some corresponding angles that are congruent. And if they are, then I can say, hey, those lines right there are parallel, and cite this as my reason. So now we have four primary postulates. We did have some other ones like ruler postulate and measuring postulate for angles, but the primary ones that we're using in proof are angle addition, segment addition, the regular corresponding angles postulate, which says if the lines are parallel, the corresponding are congruent. Now the converse, which says if the angles are congruent, the lines are parallel. We're going to start with the toughest proof of these, and that's the converse of the same side interior angles theorem. And I'm not sure if I have my pictures labeled correctly. I do, I think. Our hypothesis is that the same side interior angles are supplementary. There's already a link between 1 and 2. So in our picture, we have angle 1 and angle 2 are supplementary. Given that the same side interior angles are already supplementary, the lines must be parallel. Our goal is to using this to prove that M is parallel to N. Now we have some different things in our toolbox. Since we were not given the lines as parallel, we can't use the regular corresponding angles postulate. Cap, okay, cap is something we cannot use. We were not given parallel lines. But we can always use vertical angles. We can always use linear pairs. You might have an inkling as to which one of these we're going to use, given that we're dealing with same side interior and we're already given something as supplementary. So in this case, you're probably right. We're going to want linear pair theorem because those are supplementary. So that's going to help us with our proof. Also, the only thing right now that we have in our toolbox that proves lines parallel if they aren't given to us is converse of cap. Parallel lines via converse of cap. Now there's these other theorems that we use in proofs all the time, but when we're proving these, we go back to the postulate, what was assumed to be true, because we haven't proven the other ones yet. So here's our statements. The first thing I have is that angle 1, first off, we've got, two lines cut by transversal, yada, yada. I'm going to pretend that's in there. Angle 1 and angle 2 are supplementary. Technically, I should have all of that too. That's our given. We're trying to prove the lines are parallel. Well, if they're supplementary, that means that measure of angle 1 plus measure of angle 2 adds up to 180 degrees. That's by the definition of supplementary. Now, my whole goal in this is to prove the lines are parallel. So I really want an angle that corresponds with angle 1, and that happens to be angle 3. If I can somehow show those are equal, then I can use the converse of cap to say the lines are parallel. So my goal right now is to go from 2 to 3, and I do have a connector. I can't go straight from 1 to 3 because I can't use the regular corresponding angles postulate. I do have a connector from 2 to 3. They are a linear pair. So angle 2 and angle 3 are supplementary because of the linear pair theorem. Because they're supplementary, the measure of angle 2 plus the measure of angle 3 will add to 180 degrees. This is by the definition of supplementary again. Well, now I have a system of equations, both of which equals 180 degrees, just like we did when we were doing vertical angles, the proof of the vertical angles theorem. So since they each equal 180 degrees, I have the measure of angle 1 plus the measure of angle 2 equal to the measure of angle 2 plus the measure of angle 3. And this is by substitution or if you want, you could use transitive property of equality. Again, these are coming from lines 2 and line 4. Transitive property of equality works because the 180 is the connector. If you subtract 2 from both sides, then you get the measure of angle 1 equal to the measure of angle 3 using the subtraction property of equality. Because they're equal in measure, angle 1 is congruent to angle 3 using the definition of congruence. And since angle 1 and 3 are congruent and their corresponding angles, that will force the lines to be parallel. So we can say M is parallel to N because the corresponding angles were congruent. So our reason is the converse of the corresponding angles postulate. And that's the reason we should see at the end of all of these, unless we assume that we've proven some of the other ones before. Converse of alternate interior angles theorem. If two lines are cut by transversals so that alternate interior angles are congruent, in this case 2 and 3 are given as congruent, then the lines must be parallel. So in this case we're proving M is parallel to N. Again, since the lines were not parallel, you cannot use regular corresponding angles postulate. That postulate can only be used if the lines were given as parallel. But we can use vertical angles and linear pairs, and to prove the lines parallel, we can use converse of cap. Well, looking at this picture and seeing that I'm at angle 3, I'm actually going to do the reverse. I'm going to go from angle 3 to angle 2 through that congruency statement, and that's a given. But 2 and 1 can connect. I really want to connect 3 and 1, because if I can show they're congruent, then those corresponding angles will force the lines to be parallel. So I'm going to go from 2 to 1 using vertical angles. Well, now that that's the vertical angles theorem. Since 3 connects to 2 and 2 connects to 1, 2 is the connector in these two congruency statements, angle 3 is congruent to angle 1. And that's by the transitive property of congruence. Our very last line should be what we're trying to prove, and in this case that is that M is parallel to N. Why? Because these angles were congruent, the corresponding angles. So my reason is converse of corresponding angles postulate. Converse of alternate exterior angle theorem. If two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines must be parallel. In this case, we're assuming that angle 1 and angle 3 are already connected through a congruency statement. And in fact, I'm actually going to reverse that arrow from 3 to 1, and there's a reason why you'll see in a second. Angle 3 is congruent to angle 1 is given. We're supposed to prove M is parallel to N. Well, because the lines weren't given as parallel, we can't use corresponding angles postulate, but we can use vertical angles, linear pairs. We already have a congruency statement. We're going to try to get congruency to show lines are parallel, so we'll use vertical angles and converse of cap. These proofs are a little repetitive. These are different, though, from the first, so that's where you have to be careful. They're different from the ones we did in 3.2. Angle 3 is congruent to angle 1. Why? It was given. So we already have a connector to get from 3 to 1, and now we can get from 1 to 2. Angle 1 is congruent to angle 2 by vertical angles theorem. Now our whole goal in doing this was to show that 2 and 3, which are corresponding, are congruent. Well, you couldn't say that directly because we didn't have parallel lines. But through these connectors, one that was given and now the vertical angles, we have taken the transitive property of congruence, to say that 3, since it's congruent to 1 and 1 to 2, 3 is congruent to 2. And now that we have that this and this are congruent, that will force line M to be parallel to N by the converse of the corresponding angles postulate. I hope this helped you to review these theorems if you were looking for a way to review what we had done in class. Have a great day.